Assalamualaikum warahmatullahi wabarakatuh, and good morning to my dear students. Before we begin with today's lesson, I just want to say welcome back to school and Selamat Hari Raya Aidilfitri, maaf zahir dan batin. So today's topic will be treble graphs. So the learning objectives for today, so by the end of the lesson you should be able to interpret a distance time graph, and you should also be able to draw a portion or the whole of a distance time graph. And the steps to success would be defining the relationship of speed, distance, and time. So what are the difference between one another? Drawing up the x-axis, which is the time axis, and the y-axis, which would be the distance axis. And then you should also be able to interpret the slope of the graph. Okay, so before we look into that, let's recall what you have already known from your SPE topics. So you have looked at this pyramid, which stands for distance, speed, and time. So how do we use this pyramid is, when you want to find distance, you cover the top part. Now you have S and T, which means distance is found by multiplying speed and time. And then how do you find speed? So you cover speed, you have d over t, which means distance over time. And then the last one, you cover the time and you have d over s, which gives you distance over speed. Now let's look at an example of a distance time graph. Okay, so this is an example of a simple distance time graph. So let's look at the first part of the graph first. I've labeled this O as origin, which is the starting point of the journey, and A as point A. Okay, so when you see a straight slope like this, it shows an increasing distance. So the distance keep on increasing, but it is going at a constant speed. So if you start off here at 40 meters per second, let's say for example, so you are going for 40 meters per second for the whole first part of the journey, or also called as the first leg of the journey. When you have a flat line in a distance time graph, this refers to a stop. So the vehicle or the person is stationary, they are stopping. That's why the distance is the same for the whole journey. So if distance here is 3 kilometers and it's still 3 kilometers here, 3 kilometers away from the origin, so they are at a stop. And for this last part of the graph, you see a downward slope. So it's going back. The distance is going back to the origin. So you are moving from point A, going back to your original position. However, since the slope is still a straight line, it is going at a constant speed. But look at the first and the third part of the journey, it is a different slope. So the steepness of the slope is not the same, which means that they are not going at the same speed. So if this is 40 meters per second, but the slope is less steep, which means that it is going slower here, but it is going faster here, which also explains why the time between these 2 points is smaller than the time between these 2 points. Okay, so the slope of a distance time graph gives you the speed. The slope is the steepness, or in other words, the gradient. So if you want to find your speed for the first part of the journey, you can find the gradient from your starting point to where you stop. Okay, so the gradient of this line will give you the speed. So do you remember how to find gradient? Okay, the formula of gradient is y2 minus y1 over x2 minus x1. So if you want to find your speed from O to A, you can use the two coordinates here. Okay, so the coordinate of A, the coordinates of O. So the steeper your gradient, the higher or the more your speed. So this is going faster. Because this is less steep, so the speed is lower. so you are going slower. So here is another example of a distance time graph, but now we are working with curved lines or curve. Okay, if you look at this line, the gradient here is less steep compared to the gradient here, so you can say the gradient is increasing. So an increasing gradient indicates an increasing speed, because as we have mentioned before, the gradient of a line in a distance time graph gives you the speed. Okay. Meanwhile, for this one, if you see, the line is steeper here compared to here. So you can say that the gradient is decreasing. So a decreasing gradient gives you a decreasing speed. Okay. So how can you find the gradient of a curve? Okay, let's say you want to find the speed. Sorry, it's blurred. So let's say you want to find the speed at this point of the graph. So you draw a tangent to that point. Okay, let's imagine that's a perfect tangent. So now you want to find the gradient. So you use this point of the tangent and this point of the tangent as your coordinates. Let's say this is x2, y2, and this point is x1, y1. Now you can use these two coordinates to find the gradient. Just put it into the formula, and now you can find the speed at that point. Okay, same goes to any other point on the graph. So let's say this. So you just draw a gradient, a tangent, sorry. Okay. Alright, so now you can try the questions in the exercise, and the notes is this a summarized version of my video, and then you can look at the notes first and then try the exercises. Thank you for tuning in to my video. See you next lesson. Bye.